This is example 188 from the core maths book. So page 138. And so we're going to try and solve this equation. And again, we're going to use the identity that tan x is equal to sine x over cos x. So at the moment, we've got an equation which involves sine x's and cos x's, and that makes it difficult to solve. And we want it in terms of just one trig function. So what I'm going to do here is just divide everything by cos squared x. And if I do that, I get sine squared x over cos squared x minus sine x cos x over, again, cos squared x equals 0. So the sine squared x over cos squared x will actually turn into tan squared x using our identity, because it still holds. If we were to square both sides of this, it would still be true. So in fact, sine squared x over cos squared x is actually equal to tan squared x. For this bit, we can cancel, we've got cos squared times cos squared on the bottom. We can cancel one of the cos squareds with the cos squared that's already there. And so that would leave us with sine x over cos x. That's if we cancel the square with the cos x on the top, equals 0. And then what I'm going to do is I'm going to just use the identity again, say sine x over cos x is tan x, and that equals 0. So what we can do next is try and factorise this. So if we do that, we get, we've got a common factor of tan x, so we can take out tan x and we get tan x minus 1 inside the bracket equals 0. So that gives us two solutions. That will give us that we've got tan x equals 0, and also that tan x from the bracket is equal to 1. So we're looking for solutions in the range minus 180 to plus 180. So again, what I'm going to do is I'm going to draw our graph in that range. So this, again, the asymptotes are at 90. Actually goes through 0 at 180. And we've got another one, although we're not going up as far as 270 in this case. We've got another asymptote at 270. And we end up, we've got another asymptote at minus 90, goes through at minus 180, crosses the axis at 180. So put our asymptotes in. Then what we get is our graph is going to look like this. And we're just interested in the portion between minus 180 and plus 180. So first of all, looking at the tan x equals 0, again our calculator, if we put it in, we'll get x is tan minus 1 of 0. And our calculator will give us the answer that's nearest to 0 degrees, so it will give us 0. So it gives us this one here. And I'll just change colour so we can see a little bit better. So we've got this answer here. We've also got potentially an answer here and an answer here. However, being very careful with this one, it's not equal to, it's just greater than and less than. So we're not going to have these two solutions. So our one for x is 0, or our one for tan x equals 0 only has one solution in the range, which is x is 0 degrees. The other solution that we've got is that tan x is equal to 1. So again, we're going to put that into the calculator. We're going to find tan minus 1 of 1, and that will give us 45 degrees. So what that's given us is this value here, 45, and that's 1. So if we project it across, then we actually go out of our range. So that would be 180 plus 45, so that would be 225, but that's not in our range, so that we're not interested in that one. And so if we go backwards from there, then 45 minus 180 gives us minus 135, and that is in the range that we're interested in because it's greater than 180. So the answers we have that we're interested in our range are minus 135, 0, and 45. So now I'm going to look at this next set of identities that we're interested in, which is the identity sine squared x plus cos squared x equals 1. And we're going to try and use it to solve this equation here. 7 sine squared theta plus cos squared theta equals 5 sine theta. So what we want is for it really all to be in the same trig function. So we can see we've got a mixture of sines and coses. So that's difficult to solve like that. We want to either eliminate the sines or the coses so that it's all in either sine or cos. So we can see that because we've got a sine theta here, that would be difficult to change, but we can change a cos squared. So anything squared we can change quite easily. So I'm going to take our trig function and I'm going to rearrange it to make cos squared the subject. So we get cos squared x equals 1 minus sine squared x. And so what that gives me, if I replace the cos squared, I should say theta. So theta and x are interchangeable. So cos squared theta equals 1 minus sine squared theta. We're just using theta to represent an angle, just like we were using x to represent an angle. So I'm going to replace the cos squared theta by 1 minus sine squared theta. So what I'm going to get is 7 sine squared theta plus 1 minus sine squared theta equals 5 sine theta. And this is looking a bit like a quadratic now. If we rearrange it and tidy it up, take away the sine squared theta from 7 sine squared theta, we get 6 sine squared theta minus 5 sine theta plus 1 equals 0. So we've got it equal to 0 like we do with all quadratics. Now what we can do, we could either try and solve it like that, or if we do a little substitution, we can say, well, let sine theta equal x, and then it's going to look familiar because it's going to look like a quadratic. So we replace the sine by x. So we've got 6x squared minus 5x plus 1 equals 0. So now all we need to do is put that into your calculator to try and solve it, and we'll get that x is equal to a half, and the other solution is x is equal to 1/3. So for those two sets of solutions, now we put them back into our substitution. So we can say, well, so if sine theta is equal to a half, our calculator will give us that theta is sine minus 1 of a half, and the answer that the calculator will give is 30 degrees. So let's look at our sine graph in the required range, which is 0 to 360. So it's handy to write these values on before you draw it. And what we get is the graph goes like this. So it reaches a maximum at 90 and a minimum at 270. So our calculator has given us this value here, which is 30 degrees. And then if we project across on the graph, get this one here, which we can get by subtracting 30 from 180. So that value is 150. So there's no other values in our range because then the graph goes negative between 180 and 360. So we get another value from that, which is 150. We're now going to look at the other value, so the 1/3. So if we do that here, we've got sine theta is 1/3. And so if we put that into the calculator, theta is sine -1 of 1/3. And our calculator will give us 19.47. So it gives us the value closest to 0. So it's only given us one answer, but there are more answers in our range. So it's given us that one, where that's 1/3 there. And that value is 19.47. So again, we can project across and we can find this value simply by taking away 19.47 from 180. And if we do that, we get 160.53. So combining all our answers together, we've got 30, we've got 19.47, got 150, and we have 160.53. And that's it.